Hello and welcome to part 3 of our Ivy growth project. In this part we're going to look at generating leaves at the end of our branching system. They connect up to the petioles, so we need to make sure that they're in the right position, that they're at the right orientation, and we can kind of work out how to do scaling and even some unfurling. At the very end we'll also take a look at creating geometry for the branches, but mostly we're going to be focusing on the leaves, so let's just get into that now. And we can collapse, deactivate and hide our Ivy growth system as well, and then we reveal our leaves. So if I just show those and zoom into them in the viewport, you can see we have 5 planes labeled leaf 1 to 5. They're very simple geometry. They're actually only 2 polygons, 2 in width, 1 in height, and if we show that actually in the shading, so I'm going to make sure that at the moment it looks like they're a grid of 4x4, but actually that's just the isopalm view. So set them to wireframe, and you can see that they are just 2 polygons wide going down the center. And then the materials are set front to back. Top material, bottom material. It's just for the viewport, and we're going to convert these later for rendering, but they're going to help us align stuff and make sure things are in the right place. Okay, so really we need to see how these behave inside an xpGenerator. So let's do that now. Let's add an emitter. And let's put that at the top of the hierarchy. Let's add an xpGenerator. And then let's put all the leaves inside that xpGenerator. And I could do that just simply, I could just drag that null, Shift G to get rid of the null. And now they're all children of this generator. Now, because I had the emitter selected, the xpGenerator automatically associates that emitter with the generator. So when you add it, it does this nice automatic thing of connecting them up. I'm just going to make the emitter a defined emission so that we can kind of do a grid of these. So I'll just start with 5. I'll make those boxes much smaller just so we can focus on the leaves. It's in static mode, so it's only going to emit once. Then if we go to the emission tab, I'm just going to take the speed away from them as well. And also let's give them a bigger radius. Press play and you'll see we get our various leaves. And because the generator is currently set to sequential, it means that we're seeing all of the children represented in the particles. So each one, we get one generated for each particle. And we're going to play around with that a little bit later. But for now, we're going to take a look at the radius of the particles affecting the actual size of the leaves. So you can see they're all exactly the same size. And that is because our generator is set to, in the scale and rotation and offset tab, it's going to scale using the particles. Now I can set it to use the source object scale. And you see it respects the size of the actual geometry when doing that. But the problem with that is that we're not going to be able to scale them up nicely. We're not going to have to be able to add variation in our system. So actually I do want to use the particle radius, but I also want to maintain that distinct size change between these particular leaf types, because this one is a large leaf when I scanned it in, and this one is a small one. So I think we should keep them roughly relatively scaled to each other and then add some variation in between. And that'll give us a much more natural looking system. But the problem is that they're currently all being set to the same size, and I'll explain the reason for that in a second. But let's first of all have a look at the particles themselves. So let's jump to the emitter, display tab, and let's have a look at them as circles. And if I press play again, in the generator, I also need to make sure that the particles will display. They're displaying now, but draw mode, geometry only, I want to set it to geometry and particles. There we go, so we can see both at the same time. And you can see exactly what's going on here. The particle radius, or diameter, is actually 20 units, and it's taking the boundary of our leaf and it's fitting it to the size of that particle. And that bounds relationship between the particle size and the geometry inside the xpGenerator is how I'm actually going to trick it into normalizing our particle size. So first of all, let's just turn off our xpGenerator, and I'm going to actually drop in another, well, it's actually just a polygon object. So I'm just going to drop polygon object in, and I'm going to drop it into the leaf here, and then I'm just going to zero out the PSR there. And you can see it's much, much larger now. Now, if I just press play with that one with a child that's much bigger than it, and I press play, I need to turn the generator on. There we go. Press play. You can see now that one is relatively scaled, and it's using the outer bounds. It's using this polygon as its scaling radius. So what I tend to do is I tend to have the largest one, which is, we know it's this one, so let's deactivate our xpGenerator. The largest one is 42 units by 42 units, so let's just make our polygon slightly larger than that. So if I just make it 45 by 45, or we could even go to 50. And then if I duplicate that polygon, and just have one individually set for each one of those, and then I can go to the chords tab, or I can use the command reset PSR. It's very useful. And you can see now the large one has a different, a small delta between the sizes there. And if I turn our xpGenerator back on, so that's a simple way of making sure that your geometries stay relatively scaled if you've got multiple of them inside an xpGenerator. So now we're going to actually look at the axis of each of these objects, because currently, if we zoom in, we can see this is where the particle is being emitted, and that's actually where its center is. And it's not at the point that the leaf would be growing out of. The leaf grows out of this part here. So we need all of our axes to sit perfectly on this part here. And the easiest way to do that with the child here is to put them in nulls. So I'm going to uncheck the generator. And then each of these I'm going to put into their own null. So we can minimize those down. And we can actually name these as we go as well. Just make sure they're the same name. Oops, pasted that instead of copy. There we go. And what the null will allow us to do is it'll mean that we can move the contents of the null independent of the position of the null. And that's really useful because we can move it independently. So let's put our generator back on. And if I grab, actually, in fact, I'll leave it off. And then if I grab my first leaf here and we move the leaf, or we can move the null. So if I grab the null and I hold 7 down, that means I can move the null without moving the parent. So you can see I can move that down and I can move it down to there. We should do this in the top view. So let's jump to F2 and then let's make sure we're viewing our textures, which is, I've got it as Garage Shading, NA. And you can see that one's now centered there. Let's do it for all the other ones. So in move mode, hold down 7 and position it nice and close to the center. That one's actually, oh no, that one's too far up actually, so that's good. Okay, so 7, hold 7 down, there we go, center there, and then center there. Now when I generate and press play, our particles are at the center, our leaves are at the center of the particle growing out of that. And that's going to be much better than if they were growing out of their center. It would look a bit strange if the petiole came off the middle of that leaf when it really shouldn't. So, okay. And now we can just take a quick look at them when there's more than just the 5 original ones. So let's just change the emitter to a grid. So I'm going to go to the Object tab and let's set it to a 3D grid. And I don't need any in height, but let's have a nice 5x5 grid. And there we go. Now, because there are 5, you can see they're sequentially being assigned. And because of the particle indices, the way they're generated, we're actually getting rows of the same type of leaf. So what we need to do is we need to ensure that they're not sequentially sampling the children of this generator. So we grab the generator and we're back to this bit again, the use multiple child objects. And we could actually have it. I'll just show you the different modes. So I'll skip randomly because we'll come back to that. First child only. That allows me to just have whatever the top one is here will be generated. So if I moved leaf 2 up to the top here and I re-went, it would allow me to do that. Let's undo that. I like them in order. And then if I change it to choose by index, you can go say so starting at 1 at the top, 2, 3. So if we went for 3 and press play, that's chosen the 3rd leaf. And then the last one is assigned by group, but we don't need to look at that right now. Let's go for randomly. And you'll see that we get a nice random selection. Each of our particles is assigned a random child from here. And then we can actually hide those polygons actually. That would look nicer. So let's hide our polygons. They'll never be rendered. They're just there for the system to generate the bounds. There we go. Okay, so now we've actually got exactly the behavior we want in terms of the particles are generating, the leaves are generating at the 0 point of the particle where they should be. They're aligned. They're going to scale relative to each other, which is good. But we haven't got any sort of detail to them yet. So they're just flat planes. So we're going to work on some unfurling and giving them a bit more shape. So let me turn off the generator. Let's jump back to frame 0, turn our emitter off, and then we can frame our leaves up. I'm also going to clean up the viewport a bit, just so we can see these edges nice and clearly. Let's filter the grid off, and then also filter the world axis off. There we go, nice and clean. And we're going to focus on leaf 1. And in fact, we can actually, the bound polygons, the ones that are creating our nice relative sizing, they don't need to be a child of the leaf anymore. They can just be a child of the null. So I'm actually going to select each of the leaves with the control or command on the Mac, and then clicking them, and then I'm going to hit Shift G, and it ungroups them, and now the leaves are independent of those bounds polys. So I can work on them. Right, so what I'm going to do is I'm going to make the first leaf editable. So hit C, or there's the button up here, which is make editable. I'm going to go to a polygon mode, like so, or I could even go to an edge mode, but let's just go poly for now. And I'm actually going to use the loop cut tool or line tool. So if I jump to mesh and then create tools, it's got this line cut, plane cut, loop and path cut. And in fact, loop and path cut is the one we're going to go for. So I'm going to add that one. Let's add a cut in the center there. And then I can use this equalize to make it go down the middle. So it's exactly 50%. And what I can do is I can start moving these points so that they're more on the center line. But actually, I think we're fine to just go and subdivide this a couple of times, and we'll get the geometry we want. It's going to be a bit different for when we go for the asymmetric one, but for now, we can just subdivide this fairly simply. So if you just run the subdivide command, which is actually U and then S, I actually have it as an option. So I can say I'll have 2 subdivisions. That means we get 4 separate subdivisions or 4 segments, polys on the bottom here for each side. And that'll allow us to curve these a bit nice. It's a bit more deformation friendly. Okay, so really the only thing we want to do now is we want to make sure that this center line where the leaf is going to be bending is following the actual graphic, the image texture. So I'm going to hit F2 to jump into the top-down view. And if I zoom down into this one here, this is the one we're working on. And I'm going to go to points mode. And then if I'm in the move tool already, that's fine. Now, if your texture was a little bit too low res here, we could always jump to the material. And if we go to the editor tab of that material, we can change the texture preview size. Now, if I up it to something like 1000, you'll see it's much more refined. But to be honest, I'm happy with it at the default. It's plenty high res enough for me here. It just keeps the viewport nice and snappy. But let's just, with the move tool selected and all the axes unlocked, and in the top-down view, I'm just going to shift these over. You could just move them in X, in fact. Yeah, let's just constrain it to X. So I'm just going to have that selected. And then if I don't have any points selected, I can just interactively move them like so. And there we go. So now it's going to bend down this center line. The top one here perhaps could get moved a touch. Okay, so that's nice and straightforward. Now I want to give it some bend in the planar direction. So if I jump back to my perspective viewport, I actually want to give them some curvature, so some natural kind of bend. And what I'm going to do for that is I'm actually going to have to edit the mesh or edit the points so that they move upwards. But before I do that, I'm going to have to make sure the texture is mapped via a UV. Because currently, if I select the texture tags, you'll see that they're set to flat projection, and they're just fitting that plane, that boundary of that plane. So if I deformed this, so if I grabbed, say, this side, and I hit L and make the axis there, and then I rotate, you'll see our texture slides when it shouldn't do, when it should really be following that surface. So what we need to do is we need to just do a very simple process, which is to generate a UV. Now it automatically generates a UV when you make it editable. So if I shift and double click that, you'll see we get to view that and preview it. However, if you notice, that's a perfectly straight division down there because of the way the order that we made it editable in. So we can forget about this UVW. Let's delete that one. And then let's just utilize our texture for this. So I'm just going to convert this into a UV map. So right click it. Once you're happy with the subdivisions and the position of that central spine, I'm going to right click and I'm going to hit generate UVW coordinates. And that does 2 things. That generates the UVW coordinates. And if I hit shift and double click it again, you'll see our curve is now embedded into that UV. So that's a good sign. Close that again. And then this particular one here is the texture tag that I right clicked and ran that on changes to UV map. Whereas the other one will still be flat. So I need to change that one manually. So I just need to change that to UVW. When we're rendering this later, we'll use one material for these that can cope with a backside material inbuilt. Okay, so now we've got that curvature in and I've baked that UV down, I can actually work on giving it the curvature. So let's go into edge mode, double click this side, and then hold shift and double click down that side. And what that does is it gives us a run of those edges and then change to the move tool. And what I'm going to do is if I just move up now, you'll see that it drags them up quite sharply. I want it to be a nice curve, so I'm going to utilize soft selections. So over here in the attributes window of the move tool, activate soft selection, and you'll see it's all yellow at the moment. That's because this is too large, this radius. Let's drop the radius right down until the middle's pretty much excluded. Something like that. And then I'm going to change the shape to a dome shape. So if I do that, you'll see I get that nice curvature. If I undo that and I change it to one of the other modes, let's say needle, you see that it kind of gives it a sharp curvature that way. But the one I want is dome for this particular case. So there we go. I think that's a bit too much still on the size here. So let's just drop that down. There we go. We're getting a nice bit of curvature on there. But I don't really want the center to come up with it, so that's perfect as it is. If you want to see the texture whilst you're doing this soft selection move, you can just deactivate the preview here. And there you go, you actually get to see the texture whilst you're soft selection transforming it. So if I deselect that leaf and I go to a view mode where there's no lines, we can now see that that actually has some curvature to it. And even just that simple bit of curvature will really help sell them as realistic leaves when we're viewing them in a cluster of them on the actual full system. So we've got the bend that way, and that's sort of a permanent bend that these leaves will actually have on them. But there is another bend where they bend down this way. So what I'm going to do is I'm going to utilize deformers for that because I actually want to animate those. I actually want to have the leaf unfurl. And we can do that really simply using a combination of bend deformers. So if I just add one to the scene, let's make it a child of our leaf object. And then to quickly position it, we can just use the fit to parent option there. Now it's going to bend over this axis here. So it's going to want to bend this way. So we're going to have to do some adjusting. So you can see that's obviously not in the correct place right now. So if I actually just leave that bend on there and just demonstrate that we need to rotate this way. So across the Y and then downwards until it's facing that way. And then I move it down that way. Now if I run fit to parent, it'll be in the right orientation and actually we'll get some sort of depth to it, but it's going to be sort of correct. So now we can see we actually have it bending our leaf and it's going to give us some nice unfurling. But at the moment it is actually stretching the leaf. So if I kept going way beyond its sort of level, it'll actually stretch the leaf. And let me just check, click to keep axis length. That just means it's never going to stretch beyond what it would actually be able to in reality. So that keeps that like that. Nice. So I've got a little bit of a bend there, and we'll set some animation keyframes there, but we'll rename these, and let's call this one bend main because we're going to have a couple more for the rolling up. There we go. And we should also just ensure that the part where the particle is going to be sort of grounded, it's going to be attached to it, is here. We should make sure that the bend doesn't affect that. So we should make sure that the bend starts about here. Let's reduce it in its Y-axis. So you can see there, Y. Just a touch so it's nice and curved, but there we go. So that just means that when we animate this, it'll always be connected to the petiole in the correct place. Awesome. Okay, so now let's utilize this bend and duplicate it and create the rolling effect. So I'm going to duplicate these. Whilst I'm working on this, I'll turn the main bend off. And let's rename this one. This is going to be bend fold R, or fold L to start with actually. Let's go for this side. And we're going to need to rotate this, of course, to make it suitable. So currently, if we think about it, it's folding down this way. So it's folding from this end here. Let's hide that main as well, just so it's nice and clear. Let's rotate this one round this axis. Oh, actually, no, it's the opposite because we're going for left first. Just move it up, and you can see where it should be folding and bending there. And there we go. And we can have that. We could actually rotate it around this axis if you want to use positive numbers as well. So positive for folding, negative for unfolding, perhaps. Doesn't really matter. It's just that's just a workflow thing. So we can roll that right up like so. That's kind of cool. Let's duplicate that one. And this one is going to be essentially a mirror of the other one, but we need to make sure that it's oriented correctly. So we need to move it along this axis, and then I'm going to rotate it perfectly around that one. There we go. Now you'll notice something. It's working quite well to roll these up, and we're going to get a nice animation out of this. So if I change that one to, I should rename that R, and we grab them both. The advantage of me having rotated that in the way I did around the heading there was that I can grab these both and just unfurl them at the same time. That kind of stuff makes it a bit easier to handle. But at the moment, that's looking pretty good. We might want to have them sort of fold into each other a little bit more. So what I can do is, depending on where these are positioned, you'll see that you can kind of unfold them and have them ravel over each other. If ravel is a word, I might have just made that up, but there we go. Okay, awesome. And then if we activate the main again, where the main is in the hierarchy does matter. So if we put it at the beginning here, can you see that we're getting this? It might look quite interesting. You might want that sort of flaring, but I want it to actually stay pretty tight like that. And that means that we can really curl this up. Okay, so those are all set up. And one last thing I might want to do is if you notice if I've got one of these off, for instance, and I move this up towards the center line, if I keep pushing it past that center line, it'll just keep rolling over that other side. So I might want to restrict it to only affect one side of our geometry. And what you can do is you can grab the geometry, and I've already got this side selected, but all you need to do is select that side and create a selection. So I'm just going to go bring up the commander, set selection, and then that adds there. Let's call this one R. And let's deselect that selection, because once I set it again, it'll try and overwrite. So let's invert that selection, which is U, then I. And then let's run that set selection again, making sure the other tag is unselected. And I'm going to make that L. I'm just going to put those in order. So right there, left there, that makes sense. And what I can do is I can restrict them. So if you've ever come across the restriction tag, you'll be familiar with this workflow. But what we do is we're going to add a tag. I could grab it from here, or I could just use the commander again. Or right click even. So right click, Cinema 4D tags, and then restriction. And you'll see immediately the deformer, the left fold, just stops working because it hasn't been told what it's restricted to yet. And we're going to restrict it to the L selection. And then I'll do the same. I'll just duplicate this restriction tag. So if I change this L to an R, that means that now the right-hand side is restricted to only the polygons on this side. And likewise, the L is only on the left-hand side. And if I rotate, you can see it's not interfering with this curled up side here. Even though we're not rotating, that's just to demonstrate. And you can see it doesn't affect the right-hand side, only the left. Okay, cool. So now we've got these set up, we can turn the main back on. And whilst we're at it, we can actually see that the shading is quite sharp at the moment. So we need to increase the Phong angle on the actual leaf geometry itself. And you grab the Phong tag. We can actually just turn the limit off. So we could just go for that, or you can just increase it beyond the curve point. So right now, it's sort of shading it as if it's a lot smoother than the geometry amount suggests. All right. So let's add some keyframes and give this sort of an unfurling animation. Now at default, I want it to just sort of fold down a touch. If I turn the other two off, So it's just gently kind of, I want all the leaves to always have a bit of a bend in them. And I'll add a keyframe. Let's just deal with a shorter sequence here. So let's use the power slider and let's go for somewhere around 40, maybe 50. And let's actually add that as the last keyframe. And then the folds, the folds can go to 0 at this point. So let's have them 0 at 40. Let's go back to 0. And then we want to make sure these are wrapped up nice and tight. We can adjust their positions in a second, but essentially we want them to sort of fold up to a tube. And then the main one, we can actually have it, yeah, we could just have it roll up like that, which might not be anatomically correct, but it's going to look cool. So let's hit play. And there we go. Get our nice unfurling animation just with 3 deformers and just a bit of positioning, and you've got this really nice unfurling. And we can actually enhance that a little bit further by giving it some sort of inertia, some spring to it. And you can do that using a jiggle deformer. So let's just add one of those. Jiggle. And I've got it to add at the bottom of the hierarchy there. That's perfect. So just below the other bends. And just at default, if I press play, you'll see it gives it this sort of springy motion. Let's hide our bend deformers for the moment. And you can see it's giving it a bit of a spring motion. But there is a problem. Now, if you can see the null center here, it's just at this part here. That's actually moving when we really don't want it to. So what we'll do is we'll utilize the restriction tag again. Let's just turn all these off for the moment. And we're going to use a vertex map this time. So let's put it into points mode. And I'm going to set a vertex weight. So I'm just going to bring up the commander, set vertex weight, and I'm going to set it to 100%. So at 100%, the whole leaf is going to be affected. But really, I just want it to affect down here. I want it to exclude this point here, which the point I'm going to place is always going to be on this petiole connection. So let's double click that same tag, that vertex weight tag, and I'm going to set the weight to 0. So when I paint, I'm going to get a 0 weight. And then I'm going to set it to 50% so that these ones are just gradually included as well. Now, same process as the bend deformers. I just need to add a restriction tag. So restriction, and I just drag that vertex map, and it's just looking for the name. So vertex map. So when I copy this across, it should work for all of them. There we go. Let's turn those on again. And this time, that point in the center there is excluded. Excellent. So now we've got that all set up, we can actually ripple through the other ones. And I'll go through this one here again, just so that we can see it. In fact, I'll go through the one that's kind of got an off-centered polygon, and then we can ripple through the other ones. I'll fast forward through that. So let me just, first of all, let's grab that one, make it editable, and there we go. Now, immediately, obviously, our problem is that we've got this uneven poly here. So what I'm going to do is I'm going to actually move this one first, and I'm going to turn soft selection off. So if I go to my move tool, turn the soft selection off, and I can move over like so, just so sort of preempting where the subdivisions are going to be needed. Then I'm going to give it a halfway subdivision, and then like we did before, U and then, well, U and Shift D, or U and Shift S, sorry, and then you'll get the options dialog, and I'm going to subdivide twice, like so. Then I'm going to tweak the positions of the center line. So we're in move mode. Let's deselect those, just so I can have it in tweak mode. Grab it, release. There we go. Now I want a point on here. I want to make sure that I have a point there. So this is where we get a bit more custom in terms of the positions of the points and stuff. That's all good. Now, remember last time we have to set the UVs to this exact perimeter. So I'm going to delete this particular UV, right click the tag, generate UVW coordinates. Now if I shift double click those, you'll see it has that deformation sort of inbuilt into the UV. So when we transform it, the texture will follow nicely. And let's change the other tag to a UV tag as well. There we are. And then all we need to do is we need to transfer our deformers into there as well. So I'm going to just hold down Control whilst I'm dragging them into the fourth one. And then, of course, we're going to need to reposition them. So let's reposition them into here. And you'll see that they're all sort of, the axis of this is all in the wrong place because of the jiggle deformer. You can see the jiggle deformer is at world 0. So let's just reset the PSR on that. Let's do the same for this one. There we go. Now when I select them all, they're all going to be around this axis and I can shrink them down somewhat. So just use the scale tool, so T, until it's sort of scaled more for this size of leaf. Like so. And of course the keyframes are still on here, so we can just check this out. We can see this move. That's working nicely. Might even be able to bring that back a bit closer to the, there we go. And you can see we've got our sharp shading, so we need to put the Phong angle up at 180 or even just uncheck it, like so. And we need to add our selections to make sure the bends and stuff are restricted. So let's deactivate them for a second. And let's do our selections. Here's one side. Remember to run set selection. That one is R. And then I just U and I to invert. Deselect that tag on that side. And then run the same command, set selection. And that one is L. So left and then right there. And then because they're named correctly, they should be restricting automatically. So if I just rotate this one to test, yeah, it's not affecting the other side. Perfect. And then the same thing with the jiggle. The jiggle's going to need that vertex weight. So first of all, let's select the whole thing. In fact, we could just invert, select that point there, invert, set selection. Oh, not set selection, sorry. Vertex, set vertex weight. And that's at 100%. And you can see it leaves R1 excluded out. Then we just select these ones, double click our vertex tag, and then it's already set to opacity 50. We just do apply selected and it drops it to 50. And that should now exclude that point from the jiggle. Oh, we went back to the beginning there and it was a bit of, the jiggle might be a bit aggressive, so I'm going to drop down. I'm probably going to give it some drag just to reduce that down a little bit. So let's select them both and let's increase the drag. And there we go. Let's extend the timeline out a bit so we can see them a bit clearer. Awesome. And there we go. So it doesn't take too long to transfer those over. And I'm going to hide those deformers just so we don't have to see them when they're unfurling. Even the jiggle, actually. Okay, so I'm going to ripple through these other 3 leaves and get them prepped for animation. Then we're going to come back, work on scaling them up and also baking them to point level animation so that we can use them inside the xpGenerator with their animation. Okay, so I'll see you in a second. All right, so that's all of our other leaves rigged up as well. And as you can see, they've got their bend deformers, their jiggle deformers, all the selections they need and UVs. Let me press play and you can see there we are, our 5 ivy leaves are animating and unfurling. We've got that nice jiggle at the end, and on that we will actually check these out in the xpGenerator. Turn those both back on, the emitter and the xpGenerator. Press play and we can see all of our leaves unfurling. Now, there is something going on here that we need to pay attention to. So let's just hide our emitter. Let's zoom in on this one leaf here. Now they're unfurling no problem, but they aren't respecting once they're inside the xpGenerator and they're assigned to particles, the jiggle deformer no longer has any effect. So what we're going to do is we're going to bake the animation down to point level animation so that we're not relying on deformers anymore. And that'll give us a more reliable animation inside the xpGenerator. So let's turn that off and also the emitter because we're going to focus on the leaf geometries again. And just to keep the object manager tidy, I'm just going to collapse this. If I hold control down whilst I do this, it'll actually collapse all the hierarchy. So everything underneath will close. And I'm just going to filter to search for those leaf geometries. So I'm just going to go leaf like so. And then I'm going to open up the timeline. Now, this is the shortcut for this is Shift F3. It'll take you into the dope sheet mode. And you can see we've got these bend deformers showing. That's because they've got the keyframes on them. And in the view panel here, it's in automatic mode. Now, it might be different depending on if you've changed these ever, but what you want to do is you want to just drag these in here. So we want to focus on these. We don't need to worry about the bend deformers, only the geometries that they are deforming. Drag them in there and you see it changes the view so that we're only focusing on those. Now, quite simple here. Functions, bake objects. So the bake objects command, if we hit that whilst we have our leaves selected, and it'll pop up this dialog and it gives us some options. So we're going to start baking at frame 0 and then it'll end baking on frame 600. Now, we don't really need it to go on for that long, but we've got our keyframes ending on the 40th frame, so just over a second. However, if we set it to 40, the inertia that the jiggle provides won't be cached down either, because obviously it's going to be continually sort of decaying. The springs are going to be decaying past frame 40. So I'm going to give it a comfortable extra few frames. Let's do 120. And then bake that down to PLA, point level animation. So each point on the mesh is going to be given a keyframe every time it's moved. So essentially it's like a PSR, well, sorry, a position keyframe for each point on this mesh. We also want to create a copy. Creating a copy of the original mesh means that we don't have to worry about the losing all the deformer animation. So I'm going to hit OK. And there you go. We get all of our leaves copied over, and each of them, you can see they have keyframes on every single frame up until frame 120. So let's close the timeline and let's have a closer look at our copies here. Now, if I get rid of that leaf filter in the search bar, we can see that our leaf copies actually have some children, and it's the deformers from the original rig. We don't actually want those anymore because we've baked it down to point level animation, and it'll be doubling up on stuff, so we don't want that. So I need to clear those out. So a quick way of selecting all the children in a hierarchy is to actually middle mouse the parent. So what I tend to do is I middle mouse the parent, hold Control or Command on a Mac, and I just click the top one and I hit delete. And you can just repeat that. So middle mouse, Control on the top one, and just clear out the children. There we go. Awesome. So now those are done, let's actually remove the original rigs. We don't need those in the leaf nulls anymore. So let's move that up. Let's hit Alt-G, and let's call that one leaf rigs. And of course we can just hide that from the hierarchy. And let's put that at the bottom there. Okay, so now we can actually see our point level animation nice and clearly. Let's hit play. And there we go. So you can see the jiggle is now actually baked into this mesh. So you can see it's still an editable mesh, but the positions of the points are recorded for those 120 frames, which included that nice bit of jiggle. And the proof is, of course, in the test here. So let's put it back in the emitter and the generator, hit play. And let's zoom into that one. I could see it happening and it looked good to me. There we go. Excellent. So now we've got that jiggle actually baked into the animation, and it'll be viewable on the particles as they generate at the end of the branches. Now, there are a couple of more things we're going to take a look at before integrating it with those branches, and one of them is variation. So if I press play, we can see that our particles are all on the same frame, and therefore the animation of all the clones, the generated geometry, is all the same timing as well. We don't need to worry about this too much for our system because the way we've set things up, the XP branch modifier is going to generate particles at different times. So our leaves will be generated and scale up at the time that they are generated on the branch. So our variation is going to be given to us sort of for free naturally. But I just wanted to show you a couple of extra features of the xpGenerator that can add a touch of variation. And if we look at the animation section down here in the xpGenerator, we're just going to look at these two parameters here, the scale and variation. Now, scale is referring to the speed at which it will play back the animation. So if I set this to 50%, it's going to unfurl much slower, in fact, half the speed. And if I set it to something like 400%, they're going to expand and open really fast. So that looks pretty cool, and that gives you some control over that. I'm not particularly interested in that, but I do want to just show you the variation here. And that just allows you to get that natural variation. If you were emitting all of these on the same frame, but you wanted to still make them look kind of organic, that is a nice way. And it's just varying the speed at which they unfurl. Okay, but for our purposes, we're actually going to be all right relying on the rig itself. So we've got these animating on and unfurling, but what we don't have is that they're starting at a certain size. So even on frame 1, they're actually quite large. They're already we're already seeing them generated, and that's not going to look very good. They're going to just pop on. What we need them to do is we need them to scale up from 0, and we can do that using the XP scale modifier, of course. So let's minimize the xpGenerator, keep things nice and tidy. And I could find the XP scale modifier either by using Commander, or I can grab one from in here, and it's under the control modifiers. So XP scale, and then it's changing the particle radius. Now I need to make sure that our particle radius is 0 at the beginning. So in the emitter, the emission tab, scale set to, or radius set to 0. And let's show the emitter so we can see them scale up. And there we go. Now, currently, they're going to go up to a larger size. They're going up to a radius of 20, so they're actually enormous. In reality, these are only sort of 4 to 5 centimeters in diameter. So let's actually set a limit in the XP scale, because it's currently increasing their radius by 0.2 units a second, but they then reach an upper radius limit of 20. I'm going to drop that radius limit down to 4. There we go. They only get to that size. I'm also going to make the defined emitter a little bit tighter, just so we can focus in and still have them look nice and large in the frame. Okay, so you can see now that these are scaling up at a reasonably fast rate. I think we could probably even go a touch slower than that. So let's try 0.1 units. And there we go. So they're scaling up from 0, but they're all doing it at exactly the same rate. So let's add some variation in the radius change. And I'm also going to add it back into the xpGenerator just so that we've got some... I'll leave it down below 20. There we go. So we've got that natural variation. And you can see with the scale up that they are... The speed at which they're scaling up, the rate at which they're scaling up has a bit of a variation to it now. And that's all from this slider here. However, they are all reaching exactly the same size. And if we jump to the top-down view, it'll be even more evident. You can see that all of the particles are identical sizes. Now, the leaves are slightly different, remember, because we've normalized those, and those are supposed to be small anyway. But we want these particles to actually end up with variation. So what we need to do is we need to set this upper radius limit, but we're going to map it to a noise. So first of all, let's go to the mapping tab and add a map. Now I can view both these object and mapping tabs to help explain things here. So if I hold shift and I click on the object tab, it means that I can select and view 2 tabs at the same time, just so I can point out that we are trying to limit map the upper radius limit here. So this is the value that I want to, the parameter that I want to drive. So here in the parameter, I'm going to set that to upper radius limit. And then I don't want it to map to the age of the particles. I want it to map to a shader. So I'm going to grab the shader. And in the shader field, I'm going to add a noise. Just a standard C4D noise is fine. And I can just leave it pretty much at default, but I will demonstrate. Let's press play, and you will see that there is variation in the radius. So this one's much larger, this is smaller, but this is quite a soft sort of variation in the brightness values here. So if I increase the contrast, if I perhaps use these clipping, this high and low clip, so that the noise is much more contrasted, you'll see we get more values that are almost 0. So these are being multiplied by a near black, or maybe even black, so they're 0. And then the bright white ones will be multiplying that 4 unit value to its maximum. So that's these ones here. But we want it to be fairly subtle. And you can do the same with the color itself as well. So if I bring, say if I bring the white value down to 50%, that means no particle can go above 2 units in radius. And you see that happens really quickly because our speed. And if I go to back to 100, they can go back up to their 4 units maximum value. Now I want to clamp the minimum value that they can arrive at. I don't want the variation to be huge, but I want it to be enough that we can, just about see it. So yeah, I think that's pretty close. I think we could go up to something like 50%, like so. And that's just subtle enough that I think it's going to work nicely. So if I just go back to that mapping tab, it's currently sampling the position of this shader in a unique random way. So what it means is it's grabbing a value from across this shader, this map here, and it's just, each time it's going to grab a unique one for each particle, and then that's a way of sort of randomizing our particles. So there's no UV maps involved here, nothing like that, no need to worry about that stuff. And that's pretty much ready now to attach this to our Ivy growth system. So let's get to that now. And if we hit F1 to jump back to our perspective viewport, let's grab our Ivy system. Let's activate it and let's unhide it. And let's zoom out. Let's see what we've got. And let's just hit play and just see how, make sure it's performing. Perfect. Okay. Right, so now we need to transfer this xpGenerator and we'll put it inside the hierarchy here. We're going to have to change the emitter that it's referring to. So currently it's looking at this demonstration emitter we had. I can delete that now. We don't need that anymore. So I'm going to fold it and I'm going to go to the emitters group here and I'm just going to select the main emitter there. I'm also going to set the particular group that it's going to generate from. So the xpGenerator has a tab called Groups Affected. And instead of it generating on all the particles, because obviously we don't want it on the end of the main branch and the shoot groups, we just want it to affect the petiole group. And in fact, let's call that petiole leaf group. And then we're going to drop the scale into the modifier stack here as well, like so. And that also can just be assigned to the petiole leaf group. Now let's just double check things. Let's press play. And we'll start to see geometry forming at the end of our petioles. So it's pretty easy to get it connected up. Once you know where to look, you just need to make sure you're connecting the right emitters up and just making sure the groups are assigned correctly. Now, the first thing I'm noticing is that our particles could definitely be larger. Our leaves could definitely be larger. So I'm going to jump to the scale here, and I'm just going to go to the object tab, and I'm going to increase the upper radius limit. Now, when I do that, I'm also going to have to up the rate of change. So they could probably grow a bit faster. So I'm just going to put 0.4 there. Press play. But you're already seeing this is going to be pretty cool. If I zoom into our leaves though, we'll take a quick look at them. Now we're seeing that the petiole is perfectly aligned, so that's worked out really nicely for us. You can see they're all growing in the places that they should. But if you notice, they're actually all oriented in sort of weird ways. They're kind of following along, but they're in sort of strange orientations. So if I actually jump to the emitter, we go to the extended data tab, which deals with the particle rotations. You can see here we've got the mode set to tangential, and that's evidently working because the leaves are pointing sort of along the direction of travel of that particle when it's sort of finishing its growth. So that's working. However, there is no up vector. So they're able to sort of rotate and we're able to see the underside. So what we need to do is we just need to simply set the up vector. This is a very useful feature of the emitter. So press play and up they come. And now we'll see all of our particles are facing the correct way. So they've got an up vector, but they're facing the correct way. Now, some of them obviously will take a second to sort of orient, but they'll never be facing fully down. And actually you can see with if I just selected all of our leaf bottom textures and I just activated the luminance channel and I made it a really obvious artificial color. This is quite a good way of diagnosing these when the colors are quite similar. So you can see if I look on the underside, we're going to see almost all that pink color. And then if I look down the top side, it's working. Obviously these ones are unfurling still, but that's quite a quick way, a useful way of diagnosing if the placard or the geometry is oriented the correct way. So let me just turn that luminance channel back off. And let's deal with a slight adjustment on that rotation. So currently they're sort of sitting on the end of the petiole, but in reality, there is a bit more of an angle that they will be facing downward. So I'm just going to jump to the xpGenerator, and we can utilize the rotation, scale rotation and offset tab. We can utilize the rotation of the original geometry. We can offset the particle rotation, which is what we can do. Current default is particle rotation, but if we set it to offset particle rotation, and then I want it on the pitch to point down. I want it to point its nose down, if you like. So I'm just going to set, well, it's going to be a negative offset. If I do a really obvious one, let's do 90 degrees. When it comes up to here, you can see now they are 90 degrees to the end of the petiole, to the normal of the petiole. So let's make that a bit more subtle at 30 degrees. And there we go. So we're getting this lovely animation where they're sort of unfurling and scaling up. However, there is a consideration here about performance, and that is that if we are using straight clones, it's going to make our scene very, very heavy. So we can have that really nice unfurling, but it is at a cost. So what we could do is we could set the clone type to create render instances, and we should immediately see that the playback is much, much quicker. Now, we're still going to get some growth because we're going to get some unfurling at the beginning, because when the particles are generated at this point, that's when the animation overall of the leaves that are being render instanced starts. So even though they're at the same time, you do get some unfurling at the beginning. So there's a bit of a trade-off here. And if we have a camera down, where these begin, that might cover us nicely. But definitely worth considering. So for the close-ups, perhaps you would have the generator set to instances or straight clone, and then for the wide shots you'd use the render instances. For our scenario, we're going to use render instances, but we still get the nice unfurling and the radius growth, like so. And we could even play around with the scale. At any time we can play around with this, so we could set this to a much higher scale. And away it goes. And obviously that's too large, but you get the idea. This system is set up so that we can tweak it and make it suit any scenario. So these are a bit smaller, and that's a bit more balanced. Excellent. So let's just, I'm going to rename that XP scale modifier so we can identify it later on. So let's call it leaves scale up. There we go. And I can just double click there to view that. Brilliant. So let's take a wider view of the scene. Now this is interesting. So we've got our leaves still displaying in the viewport. And if we select our generator, this is because we are in the clone type mode, render instances, create render instances. Now, the simple solution to this is to just grab our objects and move them out of view. And just as long as they're far away and under the ground, it's not going to be a problem. And then we can just play again, and it won't affect their position because their position is based on the null being repositioned. And talking of the null, I can actually see a problem here. Well, it's not too much of a problem. In the viewport, I actually have my emitter hidden, but it looks like we're seeing particles at the end of the petiole here. If I turn the petiole trail off, you can see that actually looks like there's particles displaying, but that's impossible because we've hidden the emitter. Well, this is something that might catch you out if you're trying to clean up your viewport for preview renders and that kind of thing. The null display will actually be fed through the xpGenerator. So we need to make sure, and if just to confirm that it is the nulls here, if I put the sphere, let's turn the petiole back on. If I change the display mode to sphere, let's set the orientation there, press play, and we'll see that definitely confirms that it is the null display causing us that issue. So luckily there's an option here, you might have seen it already, that's called none. So we just activate that, press play, and there you go, that's nice and cleaned up. A bit more natural looking on the leaves without the yellow dot. What isn't looking particularly natural is the color of those trail objects. So I think we should probably make those a bit more of a natural color. So I'm just going to fold these other folders that we're not using and focus on the generators here. And let's just change the color of these to something a bit more bark color. So let's go for a warmer color and much darker, I think. There we go. And if I deselect them, there we go. All right, and we're going to focus on these XP trails actually now to create the branch geometry. And we're going to do this using XP spline meshes. So they're a generator, so we can just grab our generator folder here, go to the object tab, and let's choose our generator. And it's the XP spline mesher. Let's add one, and let's actually duplicate them. Let's create one for each of our branches and petiole even. And let's rename them whilst we're going. And also, let's connect them up. So all the spline mesher needs is a spline as in the object list here, and immediately you see geometry being generated. So let's call this one shoot 02. Connect up shoot 02 here. Same for shoot 01. And then finally the main stem, of course. And connect that up. And you can see, obviously, the thickness is way too high at the very beginning here, so we can drop that right down. And what we're going to do is we're going to step down in size, because obviously the main stem is going to be the largest. So the size kind of, we could set this just as an initial size, and we can tweak it for our scene. But I'm just going to start with a 3. And then the next shoots, let's set that to a 1. And then we could drop that down. The next ones, I don't want to drop down too much. Let's go for a 0.7. And the petioles, I mean, they are definitely... Let's start at 0.4. And you can see those are way more delicate now. The profile you'll see is very boxy though, so we can fix that by selecting them all. And you'll see this setting here called subdivisions. And that will give us a much smoother, there you go, smoother look. And the other thing I want to do, you'll notice that they have the same thickness all the way along. So the main stem here, it's actually going up to here at this point. You can see it's actually the same thickness all the way up. And what I'm going to do is I'm going to actually use the there's a spline under the size parameter here. So if I use this twirl down, I can grab this scale value, and you can see if I do it if I do it down here where it's nice and clear, you can see I can scale it down and give it a taper. I obviously want to do it the other way around though, so let's do that. I don't want it to be quite that curve. I think I want it to just kind of settle down a bit like that. There we go. And then pretty much the same for all of the other ones as well. I want them to taper off, some more than others. So let's do, I think that the shoots will be very similar. So let's have a look at those. I'm just going to drop those down a bit. You can see one down here. And just set that like that. Do the same for the next one. Not quite as far down or tapered off as the main stem. And now with the petiole, let's have a look. We could make this one a bit more sort of interesting shape, because the petiole in real life has a kind of a taper off the main stem, and then it gets actually quite big back when it meets as it meets the leaf, or where what is actually a bud turns into the leaf, it kind of tapers up again. So what we could do is we could have it give it this profile essentially. So drop down to something like this, and then it comes back up again here. So let's do something like that. So you can see it's got a bit of a taper coming down in, and then at the end it comes back up a bit bigger again. All right, so that is getting very close. Let's add a viewport material for the branches, and let's just organize them a bit better, and then we'll move on. So I'm going to create a new material. I'm going to put it on no layer. There we go. And let's set a color for this. It's going to be the branch color essentially again. It doesn't have to be perfectly the same. Maybe if we go for a darker one actually this time. Let's keep it quite warm. There we go. And then we'll drop the reflectance off. We don't need a reflectance channel, so just go to the basic tab, uncheck that, and let's assign that to our spline meshes. We can group those up in a folder, so let's just add a subfolder. Let's call it XP Spline Mesher. And let's make those children, and then I can just assign that material to the top of those. So let's play back one more time, but let's hide the geometry so we can get a nice clear view of our branching system. And we can see that our branching system is now generating geometry for the branches, the main stem and the shoots. And then at the end of the petioles, we're getting these nice leaves generating. They're scaling up, unfurling, and they're all oriented correctly as well. So there we have it. Our ivy growth system is ready to go. And in the next part, we're going to prepare our ruin scene and turn it into a suitable climbing surface for our ivy to grow up. So I'll catch you in the next part.